Okay, so I've written out most of the statement again. This, in this case, is a partial derivative of x, y with respect to what variable? Well, it's y that's being changed, so that's what's varying, right? And of course, that's when x equals 2. Okay? What would be the general expression for this partial derivative for any value of x? Well, we still think of x being fixed, we just don't say what number we're fixing it at. Okay? So I can more or less safely get rid of this. So we're going to say for general value of x, the partial derivative partial derivative z equals f of x, y with respect to y. Well, this is going to look just perfectly natural to you, I think. Now, the one thing might not look natural. It's like a dz dy, but now we have a function more than one variable. This is a partial derivative, and we use this symbol. Okay, and it indicates the rate at which z changes with respect to y as long as x remains unchanged. We're going to say that's a limit as delta y approaches 0 of f of x, y plus delta y minus f of x, y over delta y. In other words, exactly the same expression we had here, except now we're not saying it's just a 2. It could be at any value of x. Okay? And this tells you for any value of x, if I hold the value of x constant, this is going to be the rate of change of y with of z equals f of x, y with respect to y for that specific value of x. Okay? And that'll work for any value of y. Okay, well, in this case, let's just work this out. We know what the function is. Okay? Well, I'm going to write down the algebra. You're going to just watch me write down the algebra. I'll probably ask a question or two while I'm writing it down, but it's exactly the same as the algebra we've already done, so I'm just going to write it down fairly quickly. Make sure you don't have any stumbling blocks.